So the distress algorithm simply finds the shortest route, and the Google map is using it. Uber drivers are using it, okay, to find the shortest link. If they want to come and pick you up, you know, they have a map that they are looking at. Most of them don't even trust that map because it doesn't update. Okay, the maps are always behind in terms of the network, and so that is why for most network solutions you need to have, you know, an updated data sets. Are you okay? Routing is very important for emergency services. Is that okay? If we need to really quickly find the shortest route from one point to the other, it's all because we want to save the cost. Also, we are tourists and we need to actually visit several locations. In that case, then we need to use the shortest path algorithm. Okay. Now, so this is what we normally see. I don't know how many of you have actually used the shortest path algorithm before. Are you okay? So you can see that we have the blue line here. Yeah, it's actually showing you how to get from Medina Market to Malam Junction. Is that okay? There are so many options. Are you okay? You can actually decide that you're not going to go through that. You're going to go through at Atomic Junction. You go through Hachu. Are you okay? And then through Dome. Are you okay? And then you go all the way. You still get to Malam Junction, but it's going to cost you more. Is that okay? It's going to cost you more to use this route than to use that. It will depend on the traffic as well. Are you okay? And the road condition. So all this comes into your network analysis, guys. Just take note of that. Is that okay? All right. So yeah. So if you take a typical interchange, a few attributes there: time needed, whether it is restricted, whether you have access, all that data is needed. Okay. I think I've already talked about this, but let me just go over it again. The direction of a route, the restriction, the impedances, so-called impedances, speed limits, are you okay? Can be looked at. And we talked about demand, number of customers and all that. Yes, we can do an analysis that makes use of customer demand, are you okay, in the network. Okay, let's talk about this network analysis solution. It's called the traveling salesman's problem. So a doctor wants to visit several patients. Is that okay? During the COVID, maybe some patients are quarantined. Are you okay? And then the doctor needs to go and see their condition. All right. Now, how does he visit all the patients or the clients? Are you okay? In an optimal way. Are you okay? So there's a need to make use of what we call the traveling salesman problem. Traveling salesman problem. Are you okay? Now, so the traveling salesperson is like the guy that they call, I don't know what they call him, but in Ghana, there are these guys from, I think, Burkina who sell materials, like they sell trousers and all that. And you see them all over the place. Are you okay? What is his problem when he wakes up in the morning? Are you all right? They want to visit as many places as possible without, are you okay, traveling the longest distances. And that is the traveling salesman's problem. Are you okay? Anybody who walks around selling oranges on their head, they all solve this problem. Are you okay? They have it in their, well, if they are not using it, then they are definitely going to run at a loss. Are you okay? They're going to run at a loss. So the traveling salesperson has to visit a number of customers, then return to the base. But he or she needs to have the details of the shortest tour possible for the site to be visited. Are you okay? The shortest tour possible. Is that all right? That is a traveling salesperson's problem. Is that all right? Okay. So now we can also talk about isochrones. What are isochrones? Isochrones are lines joining points of equal time. Are you okay? All right. So if we give you 5 minutes, everyone, where you are now, what are the places, what are the locations that you can reach? Okay. If you actually join a line to all the points that you can reach in 5 minutes, you will have what we call the isochrone. Is that all right? So the isochrone is very important for marketing purposes. Where are customers coming from? Are you okay? In 15 minutes, I can reach these areas. Are you okay? So all these areas can be reached in less than 15 minutes. The light blue areas, and then the cyan areas can be reached in less than 30 minutes. Are you okay? All right. That gives us indication where our customers are coming from. Are you okay? All right. Where are we? All right. So isochrones. Are you okay? It's just like isobars. Are you okay? Isobars join points of equal pressure, but then isochrones join points of equal time. Are you all right? So we can look at work zones. Where are our staff coming from? You need to know. Sometimes people don't even care. Are you okay? They don't even care where their staff are coming from to give them rewards. Which staff is more dedicated? Are you okay? We don't even care. Are you okay? So we can establish what we call the cost surfaces. Are you all right? So what you are looking at in the diagram that I showed you is a cost surface. Are you all right? Later we talk about surfaces properly. Are you all right? Okay. Now let's look at this example. A furniture retailer can define a zone A, B, C around the retail outlets. And if you live in a zone A, you have goods delivered for free. You know, people do that. They say, we deliver goods for free to, our customers. If they are, where do you live? I remember, we were working on this building project, and then we bought cement, and then the dealer was like, okay, we'll deliver. Where exactly is your project? We said it's at this place. He said, okay, then we can deliver it for you at a certain charge. Are you okay? But then if you were at a certain, how were they able to determine these things? So this is where GIS comes in. So guys, isochrones for you, ladies and gentlemen. There's no lady here, gentlemen. Isochrones for you. Is that okay? If you have a question, please you can chip it in because I'm changing topics very quickly. Okay, network analysis, design issues. Most GIS claim they can do network analysis. Are you okay? That they contain network analysis. But basically what you find is that they only have simple shortest routes. They don't do much. In fact, QGIS doesn't do a lot of network analysis. Are you okay? That's some simple shortest routes analysis. You can work on your topology. Okay. But then you can't do extreme kind of analysis with it. There's something called locational allocation. All that is part of network analysis. The data needs to be up to date, accurate, and topologically correct. Is that okay? And most data that we are having, honestly, they fall short. Are you okay? They are a far cry from what is expected. Is that okay? All right. So I don't know why I put this one here. It's a considerations. How much detail is needed? Who calculates the weightings for each link and how are they calculated? Okay. All right. So obviously, once we are talking about links, we're talking about networks. The issues that come up is okay. The network data set is fundamental. Are you okay? First, you have to build a network data set. So I think in ArcGIS, you can create a network data set. So it's a shame I've never used ArcGIS in any tutorial that we've done. Yeah, but it does have some tools. Are you okay? When CAF buys a license, I'll use it. I don't have to teach you bad habits. Anyway, or maybe you can get a student version someday. All right. So we have to store the connectivity information. Is that okay? All right. Can you imagine 41 steps in building a network data set? Look at this. What does that tell you? It tells you that the network data set is actually the actual network and is the underpinning. Are you okay? Is the skeleton, I don't know, the basis for the whole analysis is the network data set. Your ability to build that. And the network data set, you build hierarchy, I'm giving you examples. Hierarchy, multi-net, meters, minutes, one way, road class, travel time, weekday fallback time. It can sometimes depend on the time of the day, the time of the week. If it is Saturday, the network is different. If it's Monday morning, the network is different. So all that has to be, factored into it. Is that okay? So in that case, we're looking at transportation networks. Are you okay? Transport. It's a whole area. We have what we call transport GIS. Can you imagine that? Are you okay? So For example, whenever the use hierarchy button is clicked, the solver goes simultaneously from origin and endpoints, omitting lower hierarchy routes. So we don't have different hierarchy routes in Ghana. I've told you that in Ghana we are on one hierarchy, one level. Hierarchy means level. Is that okay? So there we go. My class of 3 people. I tell those who don't take part in this class that they shouldn't be surprised if they are repeated. Is that okay? All right. So that is the end of this one. Wow, I didn't know it was going to take so long to just do the network analysis. Any question, Ernest? Do you have any question? Do you understand what I'm talking about? Are you good? Are you sure if I ask you a question, you can answer it? Do you have understanding? The Bible says that get wisdom in all that you get understanding. Is that okay? So if you don't understand it, then it's very critical that you make me aware. Otherwise, later on, you pay a price. Is that okay? Hello, are you all good? Are you all good?
We are good.
Okay, yeah, good. Okay, let's move on. Let's talk about the next topic. Maybe it may be the last one, but we're going to talk about several topics in this course. So take note of every single one of them. Okay, if you are looking at what I'm looking at, then you should be seeing something like concepts of distance. Are you all seeing that? Concepts of distance. Are you all seeing concepts of distance?
Yes, sir.
Okay, great. So yeah, distance, I think we all know what distance is, but the distance that surveyors refer to is actually the Euclidean distance. Is that okay?
Yes, yes, on the screen.
It is the Euclidean distance. Yes, okay. So there are other distances. Is that okay? And so in GIS, we want to be aware, we want you to be aware that we just can't say the distance from here to here. What kind of distance are you talking about? Are you okay? So the Euclidean metric or the Euclidean distance is the ordinary distance between 2 points that one will measure with a ruler. You see, you won't be taught this in surveying because in surveying it's assumed that you are using the Euclidean distance. Is that okay? All right. So the ruler, when you take a ruler and you measure a distance, anytime you stretch and measure straight, and that is why in surveying you are asked to stretch the tape, isn't it? Stretch it and make it taut. Then you can measure. That is an Euclidean distance. Are you all right? Okay. So we obtain that through the Pythagorean formula. Is that okay? So the Pythagorean formula is like this one. So the distance from one point to the other, okay, from this point to this point, P1 to P2, then this is what we are calling the Euclidean distance. Okay, it's really made up of the change in the eastern, the change in the northern, squared, and then the square root, Pythagoras theorem. Okay, finding the hypotenuse. Okay, this is how the Euclidean distance is actually determined. Is that okay? I think there's something I've missed out with the network analysis. I think it's the notes that I'm using. Yeah, my laptop crashed, so I think this notes is not the most updated. But I'm sure there's something I left out. Okay, if there's something I've left out, I'll let you know. Are you okay? I'll let you know. Service areas, I think we can talk about all that later on. All right, so Euclidean distance is like that. Pythagorean formula is used. Is that okay? All right, great. I think we all know this. Now let's move on and look at the other one. All right, so the Manhattan distance. The Manhattan distance is like the distance that the taxi drivers are used to. Is that okay? The Manhattan distance, okay, compute the distance that will be traveled to get from one point to another if a grid-like path is followed. So to a taxi driver, when you tell him that, please take me to here, and you point straight, are you okay? At rolling circle, he's not looking at that. He's looking at action. Are you okay? Those who know Medina, are you okay? Because he's looking at a grid-like path. Is that okay? He's not looking at the Euclidean distance, which is like the shortest distance between 2 points. Is all right. So in GIS, we need to know this, okay, and be able to distinguish. Are you okay? All right. So the formula for this distance between a point X and Y, Y1, Y2, are you okay, is this. So here you can see that we are looking at the Euclidean distance on the right and the Manhattan distance on the left. Is that okay? So I want to move from X to Y, but then instead of moving straight up this way using the Euclidean distance, which is obtained by the Pythagorean formula, then I'm going with the Manhattan distance. Are you okay? All right, which is going on a grid-like path. This is really what happens. I mean, in reality, this is what happens. And that's why networks are very, very important. Now, I think anybody who's done some cartography and some geodetic survey also, understands what is on the board. So there's no need for me to talk about it, right? The spherical distance, which is a distance on a sphere. Is that okay? All right. Because on a sphere, because spherical geometry is rather different. In fact, spherical geometry is a whole topic on its own. Are you okay? Remember the epsilon? Are you okay? The latitude and then the longitude are used to compute. Are you okay? The distance, but the distance that you are measuring is not in kilometers per se. Are you okay? You obtain the so-called spherical distance, which at the moment you can see we are represented by this tor here. Are you okay? So this symbol here, this is what we refer to in cartography as the epsilon. Is that okay? All right. And then this distance finally on the ground can be obtained. Is that okay? The distance on the ground can be obtained. So we need to recognize that we can actually compute spherical distance different from Manhattan distance, different from Euclidean distance. In GIS, just need to have it in your mind, the kind of distance that you are dealing with. Is that okay? All right, great. So let's move on. So we want to talk about the concept of space. If you have any question, you just, ask it and then we'll be fine. Otherwise, I'll just keep moving, talking about different concepts. The concept of space. Are you okay? The way people conceptualize space is important. Are you okay? And we, as in GIS, we need to understand there are different spaces. Is that okay? All right. Depending on how you look at things and the scale at which you look at your environment, you can perceive space in a different ways. Are you okay? All right. So that people actually learn, okay, their environment. They learn it in a piecemeal fashion. When you give birth to a baby, they start learning about their courts, their baby courts. Are you okay? And understand what is happening in that space, within that space. Are you all right? And then etc. Are you okay? We can categorize space. Are you okay? Space can be categorized. Are you okay? So look at it in terms of thematic mapping, and you will understand that. Okay, I don't want to go into the details of all that. Let's move on. We can talk about, there are a few things we will talk about under the concept of space: manipulable space, object space, non-manipulable object space, environmental space. Are you okay? Which is like city spaces, geographic spaces, which is like the whole world. Are you okay? Panoramic spaces, that is perceiving your environment by looking at the horizon, looking around, just, climbing up a high rise building and then looking out the horizon. Like when you are at CAF, the new site, and you are looking at the seashore. Are you okay? How many of you know that you can actually see the coconut trees at the shore from the campus? The map space is what we are looking at when we are looking at a map. Are you okay? When we actually scale down everything. So manipulable object space is space, are you okay, which is smaller than the human body. Non-manipulable, are you okay, space, you're talking about between the size of a human being and a building. Are you okay? Then we can talk about environmental space. These words are used. That's why we are learning them. I'm sure you're asking yourself, so why? Why are we talking about all this? You'll be using them as you go. You'll be picking a particular coordinate system and you say, this is a geographic coordinate system. And you'll be asking, why is this one geographic? Then you know that is something called geographic space. Are you with me? Environmental space is space that ranges from building size to city size spaces. Are you okay? So we need to take note of that. This is geography, basically. Geographic space, synonymous with state, country, continent sizes. Okay, we couldn't have gone straight to talk about this, but really, this is what we wanted to really talk about in this class, geographic space. Is that okay? All right, so panoramic space, like I said, the spaces that are perceived by scanning the landscape. When we look out, okay, the landscape, what we see will be the panoramic space. I don't think this is intuitive. Is that okay? All right. Now, how people perceive or experience space, like I said, could be large scale or small scale. Are you okay? And it depends on the scale at which you are looking at something or a phenomenon. Is that okay? For every concept of anything that you are studying. Are you okay? So large scale spaces over large spaces. Are you okay? And then the viewer learns the space in a piecemeal over time. Are you okay? Small scale spaces, small space, but I will view the whole space from a vantage point. Are you okay? So here, small scale is not the small scale we use in maps, in surveying. In surveying or in maps, in cartography, small scale means a large area that has been, are you okay, reduced. But here, small scale means small area. Are you okay? All right. You know how they say small to medium scale companies. Are you okay? That one is different from what we when we talk about surveying. Is that all right? All right, so that is about the concept of spaces, and we want to move on and talk about spatial aggregation and scale problem. As the elections come in, as we are in an election year, your knowledge in these things help you. The concept of the regions, the constituencies, are you okay? Ghana as a whole, and are you okay? Municipalities, are you okay? MCs, politics, people who go into politics and are very eloquent in talking about political issues and all that. They understand their geography. They understand what is going on around them. Are you okay? They understand the districts and they understand the assemblies and all those things. But we are talking about the problem with, aggregating data, are you okay, into different, different scales. So the region is at a certain scale, different from the district. Are you okay? The region is bigger than the district. So every region contains several districts. Are you okay? All right. But so how do we report data? Normally we talk about the GDP of a country, isn't it? The gross domestic product. But the gross domestic product is an average. Are you okay? And so it's not an indication. In fact, the gross domestic product is saying that everybody in the country earns a certain amount, which is not true. Are you okay? All right. So now that is the problem. Okay. Trying to generalize and say that Ghana is a poor country. You are lying. There are rich people here. Are you okay? To put it bluntly, that is what the spatial aggregation problem is. When data is aggregated at different scales, the resulting descriptive statistic may exhibit variations. In other words, the average income for Ashanti region is different from the average income of people that live at Ahonjo, because that's where the rich people in probably the Ashanti region are. Are you with me? So the resulting descriptive statistics will exhibit variation either in a systematic, predictable way or in an uncertain fashion, whichever way it goes. Okay, so there is some kind of fuzziness and uncertainty with data that is reported. In fact, in statistics, that's why we always associate, confidence level and significance and all these things coming. Are you okay? But still, there's a lot of chances. Are you okay? A lot of it's subjective. Are you okay? Most of these descriptive statistics are subjective. Is that okay? All right. So the spatial aggregation or scale problem. If you're observing economic data has got to do with, like I said, average income, things like that, GDP, inflation, IOK rate, and all that. If you are reporting that, IOK, we may notice a distinct reduction in, say, for example, manufacturing productivity for a country over a certain period. IOK, and this is a general model. Individual states may experience these effects differently. the whole USA cannot be compared to the states. The whole Ghana statistics cannot be compared with the individual regions or districts. Are you okay? All right. So the result of the aggregation is that the standard deviation of the data in question is increased due to variability in amongst what the states. Are you okay? So we are not supposed to aggregate data, but we don't have a choice sometimes to report for a region. We can't just ignore the use of statistics. We have another 10 minutes and then I think we are done. So let's talk about the modifiable area unit problem. Then we go. Like I said, it's an election year. We need to understand a few terminologies. Are you okay? Because that is how we vote. We need to vote based on what? Understanding. And as people who are learning geomatics and GIS, we need to appreciate, what is actually going on. Modifiable area unit problem. What is the modifiable area unit problem? It's a potential source of error that affects spatial study. Is that okay? In other words, the way that Africa was, for example, divided up, that is what the modifiable area unit problem is about. The way the regions in Ghana were divided up, we heard about the Western Togoland issue. That is, it's got something to do with the modifiable area unit problem. Is that okay? The fact that we can actually arbitrarily define the regions, are you okay? Or any area, we can subdivide an area up, actually poses a serious problem. Is that okay? That means that if you change them, you'll be having a different statistics. In other words, depending on how you divide Ghana up, you may end up having a different result, especially for the parliamentary elections. Are you okay? So geographical data is often aggregated in order to present results of a study in context. The context is an enumeration district or a police beat boundary. Is that okay? All right. So we need to understand that geographical data naturally has to be aggregated in order to present. So we have to do this, but then it comes with what? A price. There's a price to pay. It's a price to pay. So we divide up into zones, and the zones then tend to be arbitrary in nature. So when the white man came into Africa and he started drawing the lines around us, he said, this one is Ghana. There was an interest. It was done arbitrarily. Is that okay? But then there was an interest. It wasn't being done with the right. Peter Ampunsem, you are driving, and if you score 35, remember the day that you were driving. It's okay, I can see you. You keep on. Don't focus and listen. All right. So let's move on. So modifiable area unit problem. Different area units can be just as meaningful in displaying the same base level data. Different area units can be just, so the area unit is just dividing up. Okay, let me just show you what I mean by aerial units. So if I actually go to my whiteboard, okay, so if I have a region, okay, so let's assume this were Ghana. Okay, this is one spatial unit. Okay, spatial units. So I have you to make notes. You are driving. Sit down and listen to your lecture. And those who are not even showing up, they are in trouble. Okay, so now this is one spatial unit. Is that okay? One spatial unit. So you can have several spatial units. I'm going to subdivide these spatial units. So how many spatial units do I have? Ernest, if you are listening to me, how many spatial units do I have? How many spatial units do I have? Ernest, are you listening to me, or you are eating some banku somewhere? Ernest, are you there? Nana Bonsu, How many spatial units do we have? Mosquito.
We are here.
If you are here, answer me. I want to hear. I'm ask you a question. How many spatial units are on the board? Per the diagram on the board, how many spatial units do we have?
2.
Yes, we have 2.
So we have 2.
Sir, please a question.
So 1, 2.
It has been answered already.
Yes, it has been answered already. How many spatial units do I have?
Size 2 is 2.
How many do I have now? How many do
So
I
this
have?
one there is no clue. Yeah, it's 3.
Size 3.
Size 3. 3.
Okay. So
Now we
this
haven't 3.
that's the area. So
Yes,
these are the
yes.
spatial, the area, spatial units. Are you okay? Spatial
Yeah.
units. So 1, 2, 3. So it can be. This is what the white man did when they came. They subdivided the African continent. First, they mapped it, and then they started what subdividing it into different spatial units. But it can be done anyhow. It can be done what anyhow. So let's go back to representation. Okay, so different areal units can be just as meaningful in displaying the same base level data. So we get a part, in fact, what we call the gerrymandering. Later, we realize that that is what politicians try to do in order to win seats in parliament. They do what we call gerrymandering by subdividing in a way that will cause them to win the election. Is that okay? All right. So we need to actually carefully choose the aggregating zone. Is that okay? We need to carefully choose them because naturally, there are 1,001 ways of doing that. Is that okay? All right. As the study area for crime incident locations has especially infinite resolution, there is a potentially infinite number of different options for aggregating data. So you can divide up data into several ways, different patterns, and you store reports. And in fact, it's a cause for worry, and that is why we are calling it a problem. So you can be asked to actually define what this is. Is that okay? Numerous administrative boundaries exist. So you can talk about, in fact, the police have their own, when you talk about Ghana and the regions, the police have their own, what they call the police beat boundary. Is that okay? When you go to the Catholic Church, they have wards. They can draw their own map. Okay, in the health system too, Ghana Health Authority, they have their own polygons, and they can tell you that this area doesn't really belong to a particular, region. For them, it's not the region that you know. Are you okay? So they have their own districts and they can draw their own maps. That's what we are talking about here. Are you okay? All right. So this can be done by software. Software can take a polygon and subdivide it into so many funny, are you okay, regions, like the one I was showing you. All right, guys. It's gonna end. The Zoom meeting is gonna end. What should we do? Have we gone far? This is lecture 3. What time is it? Do you have another lecture? It's almost 10 o'clock. You have another lecture? It's 10 o'clock. When did we start? Started at 8:30.
We started at 8:30.
Okay, so how many minutes do we have to finish? 30. Can we do another 20 minutes, then we close? Yeah?
Yes, please.
Okay, so let's do another 20 minutes, then we close.
Okay. Okay.
Right. So we will join when this one ends. I want us to join. Let's use the same link to join. All right. Great. All right. So the modifiable area unit problem, we need to understand it. If you don't understand it, you can be fooled. You can be living in a country in which you are being fooled around. Elections are being won. If you are ignorant, people take advantage of you a lot. Okay, so guys, let's use the same link to rejoin. Is that okay? And then let me talk a little bit about this, and then we will close. We'll close in the next 10 to 20 minutes. Is that okay? We won't do more than that. It's an interesting topic. There's a lot that I'm talking about, so many topics, but you need to understand this topic is touching on polygons. You need to understand that this topic is touching on polygons. It's not talking about points. All right, so I'll meet you on the other side when we do the last Zoom meeting for today. Is that okay?